Okay, our last part for homework 1, part E, is derive the expressions for the overall thermal resistance for heat transfer across materials in series and in parallel. And then the second part, which we'll work on in a little bit, is explain how you would determine the total resistance of a typical home wall with brick insulation studs and double pane window glass. Okay, let's start number 1 and hop into series. Okay, so like always, we're going to start with our Fourier's law. So we're going to have Q is equal to negative KA dt dx. And since this is just going to be a plain wall, since we're just using an example, we can further simplify, we don't need the negative, further simplify the problem. There we go. So what we did here is we just made our dx our length and made our dt our difference in temperatures. Okay, so now finally all we have to do is we're going to rework our equation. So instead of multiplying by Ka, we're going to bring it to the denominator. So we'll have T1 minus T2 over L over Ka. And this bottom part is going to simplify to our resistance in the conduction. And so we can just rewrite this again for the 4th time as T1, T2 over our conduction, or we can do delta T over our conduction. So cool. Okay, so I set up a little diagram here, just like 3 slabs in series to kind of explain what's going on. So we're gonna have L1, L2, L3. So if we start doing our Q's, we can do Q is equal to T1 minus T2 R1 Q2 is going to be the same but with R2, and Q3 is going to be the same with R3. Okay. To solve for the temperatures first, when Q is constant, we're going to have hold on, I just realized these shouldn't be T1 and T2, these should be different. Should be T1, T2, T2, T3, T3, T4. Because our total heat change will just be T1 minus T4, but that's equal to T1 minus T2 plus T2 minus T3 plus T3 minus T4. Yep. Okay, so when we bring everything together, we'll get our Q to be our T1 minus T4 that we just solved. And then that's going to be plus all of our resistances. And so our final answer here should be L1 K1A plus L2 K2A plus L3 K3A will equal our series resistance. Okay, so now we're solving for derive the expression for overall thermal resistance for heat transfer across parallel now. So I just drew what it would look like to have materials in parallel, and I wrote a note that delta t equals the same. So it's going to be somewhat similar to up here, but just a little different with everything. So let's jump in. Okay, so to get started, we're going to start with our heat. That looks gross. Q is going to be 1 is going to be equal to delta T over R1. Man, it's going to be the same. There we go. So we can just do our Q total. Easy enough. So for series in parallel, we have our change in time over our overall resistance. Or change in temperature, not change in time, sorry. Over our overall resistance. So somewhat similar to up top, but still its own thing. So what we can do now is we can see up here this is going to be equal to this, and all of these have delta t in common. So we can factor delta t out, so we'll have Q total is equal to, we'll take that delta t out, and then we'll do a 1 over R1 plus 1 over R2 plus 1 over R3. And this looks very similar to what you see in physics for parallel. Okay, so moving on, we can see like 1 over R parallel is equal to the summation of I over 1 Ri. So yeah, that basically shows how many steps, or I guess stepping one step at a time, what you can get for thermal resistance for heat transfer across parallel. So now we're going to do part 2, which is explain how you would determine the total resistance of a typical home wall with brick insulation studs in a double pane window glass. So I believe this is going to have a mix of series and parallel. But I'll draw the diagram I believe is correct, and I'll jump back in. Okay, so to get started for part 2 with the insulation and everything, I just have this diagram, if you want to call it up. Move it over. So we have on our outside here, let me grab my laser pointer, we have brick insulation studs, and then we have our double pane window, which is going to be glass with a layer of air and then glass. So to find our Q net house, that's going to be equal to, we can start with a stud. We can do Q studs by conduction plus our Q insulation conduction plus our Q brick conduction. And then what we have to not forget is these outside areas like here and here, so we got to make sure we add in our outside of our house, so I guess we could call that outside, and the inside, so we can either, let's just call it inside and outside. So we'll have plus Q inside, and that won't be conduction, that will be convection, and then same with outside. So there's our first top part. I'm going to separate it with a line just so we know this is up top. Then we can do the bottom, which we're going to call Q net glass, I guess. Actually, let's just call it Q net G. So we're going to do the same thing. Q glass, conduction, plus Q air, convection, plus Q glass, conduction, and then we just have to add our inside and outside again. There we go. Okay, I'm back. I just realized these are all supposed to be equals, not pluses. I don't know how I messed that up. So let's change these, and then I'll kind of give a little bit more information on our diagram quick, because I didn't explain it too well. Actually, let's finish this up quick. So, well, we can do it at the same time. So what I'm kind of doing here for this example is I'm thinking of it as two series. So we have this top series and we have this bottom series, and these are gonna have to equal each other because nothing's changing throughout our series. So what we can kind of do to check our work is set them equal to each other and make sure that they equal if we did have numbers. In this case we don't have numbers, it's just theory. But for up top, I'm gonna do an arrow, I guess. We can do Q or R series house, and then we'll call this one down here R series G for glass. Okay, now finally, just to find our R total of our whole system is going to be equal to our 1 over, since we're in parallel, we gotta, or series, we gotta flip it. So we're gonna have 1 over our total series house plus same thing but with our glass. So there we go. That if in this case, if we had temperatures on the outside, possibly we could definitely solve this problem. And if we were given other things as well, we might be able to solve it. But that's a short explanation on how to find total resistance of a home without any numbers and solving it theoretically. So cool.